It's really nice to have Bob Tarcio back. He's been a stalwart in this industry for a long time, someone who's produced some really fine products. And so we're happy to have him here. And Bob, you can talk a few things about your products, but you kind of want to talk to us a little bit about the remote control issue and delete, delete, delete. Do you want to start there?
Sure, sure. I got a PowerPoint, but I'll start by talking
Whenever you're
about
ready.
the yeah. I mean, I'll go because it really uh, kind of goes into the same thing here. So you need to share the screen, I guess, or let me do that. Okay, so I put this thing together about really RF site management is what I call it because it includes RF monitoring and remote control, which we do all of. And there we go. So I actually this PowerPoint I kind of pieced together from another one that I used to do for the I did one for the IEEE about RF safety and using some of our products and whatnot in an RF safety program, which I'm going to touch on a little bit today too. So we've got various challenges at RF sites that we've had, for a long time. And remote control these days is mostly software driven, but hardware is still necessary for that last 10 feet. Connecting that relay up to the legacy equipment or the motorized switch or the whatever that you need a relay for or some kind of logic to get a status. And that's kind of what we specialize in is the last 10 feet of stuff. So another aspect of site management is RF safety, which I'm going to touch on, protection of your transmission system from damage. Accurate power measurement and VSWR protection are a must to comply with RF safety rules and to help you prevent costly catastrophic failure of RF systems. So these are all things that play into proper planning of an RF site. And for the past couple of decades, we've been building products in that area. We started out as an audio company, and we still make a lot of audio products, but we got into the RF line about 20 years ago, working with ERI, and we've just taken off and done a bunch of other products in addition to the power meters, motorized switch controllers, now remote controls. So the real centerpiece of our monitoring system is really our DPS 100D series power meters, and we make them in all sizes, so they anything from an N type all the way up to 9-inch EIA, and we've done waveguide, and we've done all kinds of exotic things for the ISM market. But it starts with a good instrument to measure power with. Now, I came up with this actually in kind of response to this business of the, with the FCC delete, delete, delete. And if you look very carefully at what they did, they simply got out of the business of specifying what you should use to measure power. And if you looked at the standard, that one standard, it really talks about mostly analog devices. You look at the size of the meter and the graduations and all that stuff, and that's largely. And I sort of have a kind of double-edged sword thing with this. It's I kind of agreed with what they did because that's mostly obsolete because most power measurement today is done digitally. We don't use analog style meters very much anymore, and if you do, they're really limited in what you can do with them because you can't use them for anything digital. If you're doing any kind of digital broadcasting, the analog style meter with a diode detector in it is not appropriate for doing average power measurements for high crest factor signals. So, but number one is compliance. That's the one thing they didn't get rid of. They're saying, well, you don't need to have a power meter, and we're not going to tell you what that should be. But if an inspector comes in and says, hey, can you show us that you're compliant with your license? What's your TPO and what you should be putting out, and how you gonna do that unless you have some sort of a power meter. Of course, there's the record keeping part of it too, which is showing that you've been in compliance. And a number of years ago they got rid. I was still working in broadcasting when they got rid of the logging requirement, and I laughed to myself about that one. It's the same thing. You no longer need to keep a paper record log. However, you have to show compliance that you're operating within all of your operating parameters. And I don't know how you do that unless you keep some sort of a record of it. Of course, most logging today is electronic, as we do as well, but you still need to do these things. So the FCC is very crafty. They get rid of a lot of words and a lot of paperwork, but they don't they haven't really gotten rid of the requirement that you have to do what you have to do. Third on the list is protection of your transmission system. Now, our meters are not just power meters. They're VSWR 3-strike interruption devices, and they save transmission lines and antenna components, from sustained failures. Many people will say, well, wait a minute, I have a modern transmitter. It's got the VSWR foldback. Well, that may not be enough, because particularly with combined systems, master antenna systems, you can develop an arc within the system, in a component of the antenna or in the transmission line. And certainly the transmitter will see that, or the transmitters, if it's a combined system, and they'll fold back. But that may not extinguish the arc. And we've had a couple of conditions where we've seen this, where stations all folded back to some happy power level that the transmitter was happy with, staying under the dissipation limit of the final of the transmitter, but the line continued to burn away, doing lots and lots of damage. So interrupting the RF completely is really the only way to do that. Our meters do all of that. Now, the RF safety thing, number 4, in certain situations, and I can give you an example of this, with RF safety rules, there are sites where, after you've done a measurement program, and it's usually you have to use a very competent firm to make measurements and, that knows what they're doing, that can certify it. You may be able to have a situation where you can operate your station at reduced power while work is going on a tower, for example. Case in point is New York, the Empire State Building in New York. They have a number of antennas up there that were installed. The master FM system, for example, was an antenna, a set of auxiliary antennas installed a number of years ago, and we participated in that project on the monitor system, which I'll show you some pictures of here in a little bit. And they determined that by having a certain level of power that work crews could transition through and work in certain areas on the tower, and most importantly, where there's an observatory where you have to protect the public, they figured out that at a certain power level, the stations can continue to operate, and life goes on. So that allows the broadcaster lots of flexibility. Well, the only way you're really going to be able to ensure that the power level is what you say it is to have a NIST traceable, calibrated power measurement system to be able to do that, so you can have something to fall back on. And number 5, of course, which will warm the hearts of management and ownership, prevention of lost airtime, which prevents loss of audience and business for the broadcaster. So pretty important stuff. So I still think that a power meter, an independent power meter, is important, because, once again, people will say, well, I have a power meter in my transmitter. That's really all I need. Well, I can give you many, many examples of where the power meter in the transmitter, for whatever reason, isn't accurate. And I'll give you one anecdote. I like to tell stories. I'll give you an anecdote about just a few years ago. We installed a rather large monitor system for a master antenna system. All Class C stations, so they're all running about 20 kW into the antenna. And the system has about 200 kilowatts on it. So we're measuring the output of the combiner, and then there's a power divider, which is a hybrid, actually, and we're measuring the upper bay and the lower bay, and then all 10 of the stations. We're looking at the inputs to the combiner. And we have a piece of software that we use to look at that system, and I'm going to show you that here in a bit, that allows me to look at the whole system. So one day I look at it, and I notice that the master antenna outputs are all down, look to me like about 10 kilowatts. So the upper and the lower bay were down each about 5, and then the output of the combiner was down about 10 kW from where it normally is. So I start to look at the stations, and I notice one of the stations is running at half power. So I called the site manager, and I said, hey, you might want to go into this guy's room and take a look and see what's going on. I think he's running at half power. So he went in, and he called me from the room, and he said, he says, the transmitter says 100%. I said, well, I don't think so. I said, I got 4 power meters that are telling me that transmitter is running at half power. And I said, let's do this. Let's do an indirect method measurement. So he got the factory test data sheet for the transmitter, got the efficiency factor, got the final voltage, final current, multiplied it all out. He called me back after he found all this information. He said, you're right. This transmitter is running at half power because the indirect method and the 4 BDI power meters were all pretty much in substantial agreement. So they called the station guy. He came in, they switched transmitters, and they were back up to full power again. So, you know what happened there? That was engineering by Greenie. Somebody went in there with a screwdriver and adjusted the power meter to make themselves happy on a Friday afternoon so they could enjoy their weekend. Just a couple of more things on RF safety. I kind of touched on a little bit of this already. One is to develop a measurement program to determine the actual RF levels present in operational areas normally encountered by occupational personnel, and also for the public if it's an area that can be accessed by the public. Number two, based on the above, develop an operational plan which may include reduced operating levels that provide the RF generator, that's you, the broadcaster, with reduced power operation, and at the same time provide safe operating environment for occupational personnel. Flexibility. And then develop a monitoring system that provides accurate assessment of operational conditions at a given site. So I think, well, this slide is from this other PowerPoint, but let me just go through this quickly. All of these things here, RF power monitoring, RF status indication, alarming, and logging events, we can do with our system. And one of the products that we have to do that is this guy here, which is an RF safety panel. And this is a simple go no. We developed this as a product for basically for tower climbers. They could come into a site and they could look at the series of lights here and they can determine what is on and what's off. And the green light it's safe to climb, and the red light is the RF is on and it's not safe to climb. And you can connect these indicator lights right to our power meters, and you can set a preset threshold as to when those lights will change. So at a certain lower power level, you can get the green light to come on, or if it goes above that power level, you can get the red light to come on. Some sites, the power level set, the threshold is set to about 1 watt. So in other words, you can't climb at any time, but still, still a good thing to have. And of course, typical preventive actions for RF safety monitoring is faults. You don't want the picture there on your left to happen to you. And then we have various other things. You have, visible enunciators, and then of course, things like klaxons and whatnot that can be alerted to go off to alert people not to go beyond this point. So when you tie all this together, you get a reporting system, you get accurate power monitoring, and you get oral and visual reporting of events, and then email reporting of events. So all that can be done right through these little power meters that we produce. This is a picture of the Empire State Building system, and this was quite a project. We did this back in 2017, I think it was. As a matter of fact, it was in the summertime of 17 when we did this. And what they wanted to do, and this also actually ties into this reporting system and RF safety. Empire State Building commissioned ERI to build a new series of auxiliary antennas for all of the FM stations that are broadcasting from the Empire State Building. And at the time, there were 19. Today, there are only 18. One of them left. But we built the system for 19 stations. And what happens here is when the 16 stations that are on the main master antenna and the 3 that are on the smaller what we call the mini master up there, when they want to switch to the aux antennas, they use our motorized switch controllers to do that. You see there's 19 of them in the rack. There's 10 in one and 9 in the other. So they go onto 2 different antennas. So we provided all the switching equipment to interface directly to the ERI switches that were installed, a monitor panel to tell which station was on which antenna, and basically a programming system that will allow you could have all stations go over to aux antennas, or a select group. You can throw some switches to do that. And then, of course, our RF safety panels are there. You can see them at the top. They're all lit up in red. And this was a system that we turnkeyed. We brought this down into the building and we installed it and supplied it. But I think the most important part about these systems that we provide to master antenna clients is that, unlike some other systems that I've seen over the years, everything in that rack right there and those two racks are uh, standard pieces of equipment that we make every day. Each has a model number, a serial number, and a technical manual and support. There's nothing custom in that system. Everything that's there can be supplied to anyone. And so parts support and that kind of thing is never a problem. You know, one of the things that I observed over the years of going out to a lot of these sites is that the antenna companies, whoever they are, whether it's ERI or Dielectric or Jampro, they're very good at RF. This kind of stuff they're not so good at. And so what they'll do is they'll partner with somebody, or they'll just buy a system from someone who says, hey, I can build a monitor system. And it's, you know, I hate to use this analogy, but it's always the two guys in a garage thing that come up with this great system. And they buy an RF sensor from here and a piece of hardware from there and some kind of an industrial computer from there. And they put it all together. And maybe one of those guys is a prolific software guy and he writes a bunch of code to make it all work. And they install it and it's all great. And then about a year or two later, things stop working. And those two guys are on to bigger and better things. And you're left to figure out where you're going to get parts for that system and how to maintain it and all of that. So we recognized that a long time ago. And we said, no, we're going to build standard products that we build for everybody. So everything, as I said, everything you see in that rack, you could buy from us today. So I mentioned this panel viewer software that we offer, and actually I could bring up an actual live customer that's using this. But basically, what this does is it's a piece of software that looks at all of our power meters, regardless of where they are. This one says Empire on it, but that's just an example. And all of this is done by SNMP V2. Every product that we make now that's Ethernet is an SNMP V2 agent. So we can gather up IP addresses, and it can be from co-located at one site or from different sites, and you can monitor things across a market or across the country or wherever you want with a system like this. So get into some of the stuff that we make here and make your life a little easier getting into the remote control part of this. As I said earlier, the remote control business has really become a software driven thing. And the stuff at the transmitter site is really a box that probably interconnects to this or that. And, like our motorized switch controllers, like our basic SWP 200 series here are no different. Again, this is an SNMP agent RF switch controller. These will handle either one or two switches. This particular model is designed to do with a single switch, it's designed to do main and aux transmitter switching. If you have the two switch model, it's designed to do main and aux transmitter and main and aux antenna. And it manages the interlocks accordingly so that if you move either switch, the interlocks will open to both transmitters, and it'll do things like sense the loss of RF and switch over if you have one of our power meters connected to it. If you have a high VSWR condition, it can cycle over to a standby antenna. So this is all stuff that's kind of built into these controllers. Now, we also make a complete set of kits for interfacing transmitters. If you noticed on that previous slide, I don't know if I can go, let's see, can I go? Yeah, I can go back. You'll notice a bunch of D-sub connectors, and most broadcast guys hate D-sub connectors because you got to get a soldering iron out and you got to wire this and you got to do that, put the shell on, and those shells never go together very well and all of that. Well, to tell you the truth, personally, I hate them too, but as a manufacturer, we like them because you can do all those connections in a single rack unit. So to tamp down some of your frustration in doing an installation, we came up with these installation kits. Now, this is a kit that it's actually half of it. When you buy the kit from us, you get two sets of what you see here. This is a transmitter interface kit. And what it does is it plugs into the back of the controller. It's two Cat5 cables. They're really just Ethernet cables. It's not Ethernet, obviously, but just two cables that you can connect to these interfaces that go inside the transmitter. And then you get the basic connections, the external interlock input for the transmitter on and off connections. And then if the transmitter has an on status and you want to see that on the controller, you can bring that cable back out, and that goes into another connector on the controller. Now we also make switch cables too. So you can start at the beginning of the alphabet, Delta, Dielectric, ERI, Mega MCI, Myatt, Spinner. If I've left anybody out, we've made cables for just about every manufacturer. And if you don't if you have a switch that you maybe have some question about how to interface it, call us. We can work with you. I don't think we've ever failed at that. I think we've always been able to make an interface between a motorized switch. So now, if we step up to a real remote control, this is our remote control offering. This is the SWP 300 series. Now, what this thing is, everything I just said about the SWP 200, which is our basic switch controller, is built into this unit. And in addition to that, you get remote control, the conventional remote control functionality. You get status inputs, relay outs, solid state outputs, and you can attach your switches to it. So it's a very compact way to get a site going, an inexpensive way to get a site going and have remote control. So it's even got some analog inputs. It's got 4 analog inputs. Provision that you can also interface our RF switches to, or our power meters rather, to the back of the controller, and you have a complete monitoring system for a site that way. Now, not enough channels. Well, we added the Aug14 panel, and that one right there is the first version of it. And I'm sorry that my camera's not working, because I could show you that we have a new version of this that we just introduced. This unit was designed to plug directly into any of our SWP series controllers. So if you want to add more remote control, you just plug it in. It was a serial connection. Now the new version, which looks virtually identical to this one, but it has some additional features. First of all, it's Ethernet, so you can use it as a standalone product. You don't have to have the controller plugged into it to use it. And it's PoE, power over Ethernet. So you can plug it into a PoE router, which will power it and make your connections, and you've got a remote control, 2 rack units. You can still interface this to one of the SWP series controllers if you want to, but you can operate it standalone, or you can do it with 2 different IP addresses, or if you want to consolidate it down to 1 IP address, you just plug it into the controller and use the controller's IP address. But we think this is, and by the way, because as I said earlier, all of these products are SNMP agents. You can use these with even our competitors' products, like the Burke or ArcTouch Plus or a Davicom Cortex unit or Relia or Statmon or anyone else that's doing, an SNMP manager product and software. Roden Schwarz, for example, has a very, very nice site management software package that they offer. All of those products can be interfaced directly to any of our products, because every one of our products is an SNMP agent. So if you look at these products, you say, well, it's pretty nice, but it's not big enough. I need more control. I need more of this. I need more of that. You can start out with a smaller system like we have, and if you have to expand it and you really feel like you have to have, the big dollar remote control, you can go ahead and do that, and you haven't wasted any of your resources, because you can plug our equipment into them and operate them. That goes for our audio products too, by the way. I'm really not going to talk about those too much today, but any of our Ethernet-based audio products, you can do the same thing with. This is the GUI for the controller, and you can see there's a power. There's this is a single switch controller, and then you have the 2 power meters that you can monitor, and a bunch of other stuff here. What I can do is I could actually have one of these running in the back here. I could actually bring up the GUI if you want to see the rest of it, but it's pretty standard stuff. We do everything on a tabular basis here. You can open up a tab and you can do your setup, your initial setup, and control your relays and control, look at your status inputs and that kind of thing. This is the dashboard screen, which kind of gives you a view of everything. So you can see which relays have been energized, or you can see which GPIs are high or low or whatever. And if you want to know what these things are, well, you go to the actual page for them, and it, where you can label it and see what that, number 2 light actually is. Okay, now other switch controllers that we make. This one is the ISC200, and this is an independent dual switch controller. And what this guy does, what sets this one apart from the other two switch controllers that we make is these are independent. So you could technically you could put 2 stations with main and standby transmitters connected to this controller, and it's a really lower cost way to do 2 stations worth of switching. Now this particular product doesn't have quite as many features as the SWP series products do, but you can connect, again, anybody switch up to these. There's a local GPIO for conventional remote control, and it's also Ethernet with an SNMP MIB, so you can connect it to your your SNMP based remote control system, or you can just use this as your remote control if that's what you want to do. Because for every one of these products, we have a graphical user interface like this one right here. And again, it's select a tab for which switch you want to control and see what's going on. There's a setup screen, and we also do logging too. So every time that switch is cycled or a transmitter is turned on or off, it'll log that event. And you can download a CSV file of events and have a record of all of that. Now,
Was that last screen you were showing a web-based interface or a local machine-based interface?
this here, this one,
Yeah.
this is web-based.
Okay.
The units themselves always have, they have front panel controls, so that, buttons, so that you can, you can select, you can push a button to turn. This is more menu driven on the front panel because there's a lot more going on here. You have to select which switch you want to control with the down arrow, and then you push which switch which position you want to move it to with the F keys. And there's a pair of F keys for switch A and switch 1A and B and switch 2A and B, and then you use the up arrow, I think, for selecting, turning transmitters on or off, that kind of thing. We really kind of develop these things more for the GUI because the GUI is a lot easier to manage. But you can step up to the front panel and do basic control of these things, and that goes for any one of the controllers that we make. So this is a third controller that we came up with. Again, this was something that came out of a project that we did, and we turned it into a standard product. This is a mode controller, the PDC 300. It's a multi-switch controller, and we designed this specifically for combiner systems. If you take a look here, this was a system that we supplied everything for. We supplied power meters and a monitor and protection system and interlock system and everything. And what they had was a power divider, which was actually a hybrid. It was a 4-port hybrid. So they have a switch feeding the output, and then there's a switch on each of the bays of the antenna. And the idea here is that you could switch around the hybrid to get to the upper or the lower bay if there was an issue with one of the antennas. So you could still operate at half power on either the upper or the lower bay. So we developed this product that, you can select the 4 modes. There's actually a test load on that system too. So you could run the whole 200 kilowatts worth of power into a water cool load. I think they did that exactly once. But again, this controller manages all the interlocks. It has an output for the half power force input, so that when it selects either the upper or the lower bay, it'll send a signal off to a T-bar relay, for example, that tells all the stations that you should run at preset power. It gives them a closure for that. For that system, we provided a master antenna interlock, a station interlock, and the half power command. And difference between the master antenna and the station interlock is one is a broadband event. If you have a VSWR trip on one of the the antenna feeds, or going into the power divider, you want all the stations to shut off. If you have an issue with a particular combiner in the system, you only want that station to shut off if they're having a VSWR issue, or somebody throws the lockout tagout switch or something like that. All of that stuff can be integrated into our system. And then, yeah, here's my attempt at humor here. Just one more chassis that looks like all the rest. You get the idea. We use the same chassis for just about everything. This is our SWP206 product, which is our antenna monitor system for master antenna use. What this box does is it manages the interlocks in such a way as I just described. If you have a master fault with, all which would affect all of the stations, it'll issue an interlock open to all stations. If you have a fault with one station, or there's an interlock event that would, cause that station to go off, like a lockout tagout switch being thrown or something like that, then only that station would go off. So it's managed interlocks. And power meters connect directly to this with a Cat5 cable, and we basically do everything with Cat5 cables these days. It's we don't do too much with crimping tools and that kind of thing anymore. This product does have a very simple GUI, but most customers use the panel viewer software to look at all the meters. But if you have a smaller system, that this product and the power meters, a few power meters, if you have a combiner system, let's say maybe 2 or 3 or maybe 4 stations, something like that, really all you need to do is have this product, the SWP206, the power meters, and that's pretty much all you need. And you can control the interlocks that way, send out an interlock closure to each station. And then you could use this GUI, or you can use the power meter GUI itself. Whoops, I skipped over one. Now, this is something that we started out. One great thing about going out and doing installations is you learn an awful lot about how not to do things. So I'll never forget the first system that we were commissioned to do, which was not one. This was before we were manufacturing any of these products. We were basically an audio company, and a friend who owned an antenna company said, "Hey, can you help us with a monitor system that we kind of conceived, and can you go and install it and come up with an interlock system?" And we did. And I think after we got done with that project, and this is going back nearly 20 years ago now, we said, there's an opportunity here to develop a bunch of products to make our lives a lot easier. And so every one of the things that you've just seen, the motorized switch controllers, the various types of controllers, the antenna monitor, the power meter itself, and even this product, which is a fairly recent addition, this is the ICP 800 interlock consolidation panel. What this does is that you can connect up to 16 of our power meters to this panel. And it consolidates all of the interlocks that are associated with each combiner, let's say on a combined system. So each module of the combiner, you could have and we supplied this panel up to a client up in Canada, as a matter of fact, at the CN Tower in Toronto. And they wanted to monitor each input of the combiner from the station input, and they also wanted to look at the reject load. This is it's a constant impedance type combiner, so there's a system reject load, and they wanted to monitor what was going into the load. And then they also had the broadband meters. They had a power divider, same thing that you just saw on the previous screen there, and an upper and lower bay. So there are power meters on every one of those ports. They all consolidate into this panel. And if you look at the front, it looks just like that RFS 120 panel that I was showing you before. It has the same series of lights on it, and it has the same functionality. So it provides you with a RF safe or RF on indication, and all of your interlocks. And you notice there's a D-sub connector there. You can plug in the SWP206, which has the interlock information for as to whether it's a broadband or a narrowband event. You plug that in there, and when you're all done, if you look at the very bottom of the green PC board there, you'll see a pair of there's a series of plugs there. That's the interlock connection for each station. So rather than having to sit there and figure out how we're going to route interlocks, I've got to go through this patch panel, we got to go through this switch, and we got to do all of that. You can do all of that through our controllers and this panel. and it's all pretty much plugs together with mostly with Cat5 cables. And then the only thing you have to run off to the station is a pair of wires, and that's it. So, and there's complete bypassing for all this. You notice there's a bunch of jumpers there. We supply those with installed so that when you put this panel in, all the interlocks are made, and then as you add things, you can remove those plugs to test and make sure that your interlock connection is there. So we tried to think about a lot of these things from the installation point of view. And we shipped these up to Canada, and we offered our installation services up there, and they said, no, we think we can do it on our own. And I thought, well, this is going to be a nightmare. I'm going to be getting phone calls from these people every day when they go to install this. And I have to say, we didn't. I fielded one or two calls. They had a couple of questions, and they were able to install this entire system themselves. That's the power meters, this panel, a series of panels, the SWP206 controller, and some other accessory products that we make, like pressure sensors and things like that. So we've tried to make this as installable in the field by the user as possible. And I got a few other little items that we came up with. This is a relay panel, the RLY120, which is basically a T-bar maker. You can take 12 relay connections, and you can have them all controlled by one closure, or you can operate them individually. And again, we did this for master antenna systems. If you have a smaller system, like where you might have a combiner with 3 or 4 stations on it, and you really want to go ultra inexpensive, you can put one of our power meters on the output of the combiner feeding the antenna if it's a single port. And then you can connect the interlock relay on the power meter to one of these, and it can fan out as many interlocks as you need. It's not quite as elegant as the SWP206 system, but it will provide you with interlock protection. And these are kind of a little out of order here, but this guy here we came up with, if you have an older RF switch that still uses 120 volt AC control, Delta used to make them that way, MCI used to make them that way, and you want to interface it to a modern controller, and you want to get the high voltage away from the rack, this little module we came up with so that you can connect on the right-hand side here, the little blue barrier strip, you connect the switch stuff up to that, and all the 120 or 240 or 120 volt control stuff will go to the switch, and the little modular connector there you can plug into our switch controller, and it directly interfaces and isolates everything for you. That's something else that we came up with. Finishing out the RF site stuff, we introduced a few years ago this guy here, an SCA generator. And you might say, well, Bob, gee, nobody's doing SCA anymore. You'd be surprised. There are more stations doing SCA than you would imagine today. A lot of the public stations are still providing reading services for the blind. I can tell you here in the New York area where we are, there's still many foreign language broadcast stuff on 67 kilohertz subcarriers. And the only company on the face of the planet that's building a standalone generator is BDI. Yes, you can get an SCA generator that's built into the transmitter if you have a new transmitter, but if you don't and you need an SCA generator, we developed that product. So this is the GUI for it. It's a completely DSP based product, by the way. So that's why there's literally no knobs on the front of it or indicators, because there's just really nothing to control other than you can do it right from the GUI here. Also an SNMP device, so you can interface that to your remote control system if you like, to turn it on, turn it off. It has all the standard stuff. It has an AB input switcher, which we thought this was a good idea. We came up with a 2-input audio switcher for the very simple fact, and Bill Robertson, who's on with us today, will probably like this. And if you want to you have your EAS generator rather audio patch through your SCA channel, you can do it because you can have your A input as the program audio, and then you can have it commanded to the B input if you are running an EAS test, or if there's an actual EAS alert. So and think about that for a minute. If you got folks that are sight impaired, for example, this is their radio, and to alert them that there's something going on is pretty important. So we thought we'd add that. So this is something that we put in there. All the rest of the stuff is pretty standard stuff. Preamps that you can turn on or off, different values of preemphasis. I think we have 75, 150, and 225 microseconds. There's a low pass filter. There's a mode select. So we even, abide by the old FCC rule where you can put it in the auto mode, where it'll mute if the audio is removed from the SCA generator, and if it returns, it'll start running again. So you can only have it running when you need to, or you can just force it to on or off. Some other uses for these. Every time I ship one of these to a customer, if they call and have a question about something, I always ask them, "Gee, what are you using this for?" And I had a guy that told me, this is something that I used to do when, years ago when I was an engineer at a station, and we used to use the SCA for IFB, for talkback. Now, we have all kinds of digital means of doing things, but if you want a really simple way to do it, I mean, you have an SCA receiver, you put that in the headphone of one earpiece of the talent, and the other can be the air feed, and you have an inexpensive talkback system. They were using this in a helicopter, believe it or not. So they had an SCA receiver tuned to their station, and was for helicopter traffic reports, so they could alert the pilot to what was going on. So I thought that was a pretty novel use. So to summarize everything I've had to say today, RF monitoring and status can be added to give complete dynamic picture in real time. So we still think that accurate RF power measurement devices that have a NIST traceable calibration that's important. As a matter of fact, oh, I don't have it here. I put it in the back. I don't have my camera working, so I can't show you anyway. I could be making faces at you guys and you wouldn't know. But we provide a calibration sheet with every meter that we ship, so you have an idea of what the accuracy is or what the error is in the meter. Our safety starts with numerical and calculated fields to determine the safety level, and sometimes verifying that with a power meter to know that you're at a particular RF power level, that it's safe to climb after they've made measurements at that power level. RF monitoring systems has a built-in fail-safe property for assurance that info and status is current. The fail-safe thing is a big deal. Our stuff still adheres to that fail-safe idea that if the equipment that's monitoring the system fails, it ought to open an interlock and let you know, because you could be blissfully unaware that your power meter, for example, is not reporting to you that you have a very high VSWR, or in the case of our meters where you can plug accessory things into it, like a temperature sensor or a line pressure sensor. You can get an email alert that your pressure is fallen from 4 pounds to 2 pounds or something like that. And, you can get an email about that before that becomes a real problem. Same thing with VSWR. If you see your VSWR rising, well, you're going to want to do something about it. And we can send emails and you can get alerts for that. And then record keeping, pretty important. And our power meters generate a log and can email them to you on a periodic basis that you can program. Our controllers do the same thing. They don't email, but you can download the logs from those and keep for records. And effective remote control solutions that keep your budget intact, along with your sanity, and keep your station on the air. And that, my friends, is all I have to say about monitoring and control and remote control, at least for today anyway. So stay tuned. We always have more products coming.
All right, Bob. Thank you very much. Harold's got a question for you.
Sure.
All right. So, okay, good. I unmuted here. So yeah, very interesting stuff. Many years ago, in the NAB Engineering Handbook, I proposed these dial-up remote controls could fax the log to you. So times have changed since then.
Yeah.
On NIST calibration of power meters, how often do they need to be recalibrated, and how can they be recalibrated?
Well, we recommend, we used to say you don't really need to recalibrate them because they're pretty stable, but, things do happen. And, so we would recommend, I would say, it used to be an annual calibration, but we have customers that, our ISM customers, for example, they'll send their meters in on a routine basis, on an annual basis. But, to me, I don't really have a recommended calibration period, but I would say, 5 years is probably a good number because, we know that we've gotten meters back in, Harold, that we've built. We've had two different versions of these meters that we've built over the years, and even the first version that we built, starting in about 2008, which was an analog sensor that had an analog output that fed a separate A to D converter, and and all that stuff. And I've gotten those back and checked the calibration on them, and they haven't budged in 10 years. So unless you think there's something up, I think, it really is, it's really at the discretion of the user. But certainly it's never a bad idea to do it on an annual basis. In general, you can do calibration one of two ways. If you want to send us the whole meter with the line section and everything, you can do it. And we'll sweep the directional coupler, and we'll recalibrate the power sensor and make sure that the calibration is still within tolerance, and send it back to you. Or you can just send us the electronics and leave the directional coupler in place. That's the one nice thing about our meters, that you can remove the electronics package without disturbing the station's operation. And because our couplers are 60 dB down, you can run the station at full power and undo the connections down to the coupler and send us the sensor, and we can recalibrate the sensor. But it's the stuff has gotten a lot better. I honestly think our competitors tell you that you need to send the meter in every year because they like to make money. And well, we do too. It's not that we're, we charge for a calibration. It's not that we do it for free or anything like that, but we just don't think it's as necessary anymore as often. Let's just put it that way.
Very, very good. The thing of sending back or leaving the line section in is interesting. How interoperable are the line sections? What's the percentage error if I just swap the electronics between different line sections?
Yeah, you really can't do that. They have to be kind of married together. There's a whole proprietary process that we use to basically, each directional coupler has its own response characteristic, and that's what it's calibrated to. So the answer is, if you use two like couplers from the same manufacturer, and we generally buy them from ERI, we don't make our own couplers, they'll typically track very, very well, on the same frequency, but we can't guarantee the plus or minus 5% of indicated reading if you take a sensor off of one coupler and marry it to another coupler. You just can't do that. If you wanted to send us, if you had a different directional coupler and you wanted to send it to us and we could sweep it and calibrate it, we could do that. But in general, again, these directional couplers are made. You have to understand, we don't sell a directional coupler and a power sensor. We sell a true RMS inline power meter, which incorporates the electronics and the directional coupler. It's sold as a composite product. We do not sell them individually. So that's why, we can ensure a calibration, because we have swept the directional coupler. We know what its characteristics are, and we know what the sensor characteristics are. We have a proprietary process for doing that. And so they have to really kind of be, they have to be married together, basically. But to answer your question, if you're looking for a relative indication, it's probably going to be, it could be anywhere from 5, 10, 15% off. I don't know, Harold. I don't really know what the answer to that is, because it also depends on how granular the measurement is of the directional coupler. So, it's a lot of things to play into it.
So if somebody does send back just the electronics and leave the line section in place, are you pretty much calibrating the electronics based upon your record as to how that line section behaved?
Yes. We have records of all of that. We have all the records of we have the serial, in other words, when you send back a meter, the meter has a serial number on it, and there's a directional coupler serial number that goes with it. So we know what directional coupler you have with that meter, and that's what it's calibrated to.
Very good. Thank you. I noticed one of the deleted rules proposed here was for television power measurement, saying it shall be calibrated with a calibrated dummy load or other method approved by the commission.
Okay, but that's fine. Calibrated dummy load. Um, that dummy load probably has a power meter in it, or it might have a calorimeter in it, one or the other. There's some kind
I
of,
assume it's a calorimeter, I think.
yeah, yeah. Well, in other words, there's some sort of of a an instrument to measure the RF power. It's, as I say, it's there. I think what the commission did is they said, look, it's up to you how you want to measure it, but um, you have to, you still have to show compliance, which is what you basically just said. In other words, as long as you can measure this into a dummy load and determine what the power is. Calorimetry, to be honest with you, it's no more accurate than what we do. As a matter of fact, a number of years ago, we were up at a client site. This was an ISM customer, and they wanted to do a shootout between our meter and a calorimeter that they had. And I said, okay. So we put the two things in series, and um, gentleman I was with, that we were up there marketing this thing together. We private label for another company actually in the ISM market. We don't actually at the present time we don't actually sell BDI branded meters to the ISM market, but we're up there and we did this little shootout, and this is a company that makes solid state amplifiers for the semiconductor industry, which is a big customer for our stuff. And the calorimeter and our meter were within 1% of each other. And when we left, I said, we got lucky today, because we generally say plus and minus 5% between two different measurement indicators, and a lot of times it's only a couple of percent. But that's another thing. We get calls from customers. They put a meter in and they say, well, it doesn't read exactly what the transmitter reads. I said, well, it's probably never going to read exactly what the transmitter reads, because there's always a delta between the two devices. There's a reason why we have a calibration specification. It's plus and minus 5% of indicated reading across the dynamic range of the meter. But the reason for that is that there are a number of uncertainties that you have to take into account, including NIST. NIST, if you look at, they have a number of good papers online talking about RF power meter calibration. And about the best that they can do, if you were to send them a power meter and they calibrate it for you, the best that they can do is 1% to the NIST standard. So, we use, and everyone else uses a secondary standard, and that's calibrated to NIST. So there's 1% right there. And then when we do our calibration, we do a data sheet, which is basically measuring the meter against theoretical, what it's supposed to read and what it's actually indicating. And generally it's within 1%. That's the sensor, but not everything, because now you have the directional coupler, and the directional coupler has to be swept, and you have to use a VNA to do that. Well, what's the spec on the VNA for accuracy? You guessed it, it's probably plus and minus 1%. So all of these errors are additive. So you have all of these uncertainties that you're putting together. Then there's mechanical, there's environmental, there's temperature variation, all of these things. That's what adds up to that plus and minus 5% in a real hurry sometimes. And sometimes the two different meters, the one that's in the transmitter and the one that's in the line that we've supplied you with, or anybody else has supplied you with, don't agree, is because those deltas may go in a different direction. And that's just a fact of life. Generally speaking, I would say they're usually within a few percent of each other.
Okay, anybody else have a question for Bob before we let him go? If you have a question, press your space bar or alternate A, or raise your hand, and we'll see that.
I had one more thing. The thing on 2 meters disagreeing, well, maybe it's a couple of things here, is there's the story about the person with 1 watch knows what time it is and the person with 2 watches doesn't. And I think the basic standard for power measurement is calorimeter, since it goes back to the basic physics. So many watts is going to result in so much temperature rise.
But Harold, that's in a perfect world, though. In other words, you got to look at the uncertainties that are associated with a calorimeter.
Yeah,
You know,
you've
you
got
have
the
it,
flow rate, you've got the
flow rate,
temperature measurement.
yeah, right, all of that stuff, the purity of the water, you got it. It's all of
Yeah,
that stuff. So you have uncertainties there too. So
yeah, that's
it's
true.
no free lunch.
You mentioned RMS measurement. I'm curious as to how you're doing the RMS to DC conversion.
The same way HP has been doing it for 65 years. That's the answer to your question. If you've ever looked at an HP power meter, and look at how they work, um, it's basically the same thing. You're comparing a reference to an incoming signal and getting a different signal. That's how it's done.
Is that a thermal measurement?
No.
Okay, thank you.
Okay.
You know what? I love I love to answer questions from smart guys. Like Harold's a smart guy, and I really have always had a lot of respect for Harold's ability. And you know, he was a manufacturer at one time and built remote controls, built some really nice ones. So I appreciate questions from people like Harold. Thanks, Harold.
All right.
Yes,
Anyone
I try
else?
not to take over.
Anyone else like to chime in? And again, press your space bar or alternate A to unmute.
I was just going to comment that in a previous webinar about digital AM, some of the stations are doing full digital, and it's kind of come to the attention that the old thermocouple ammeters actually are an analog meter that actually works pretty well for RMS. Of course, you can't find them anymore.
Right. Hey, I appeared back on the screen again. How come? Well, we can measure digital AM, absolutely. As a matter of fact, we've shipped some meters overseas, some high powered ones too. One was a 100 kilowatt, and so we can do it. And that's the right way to do it, I think, because the problem with any of, you know, a thermocouple or even a diode style meter when you're measuring high crest factor signals, such as, you know, OFDM, or, you know, for the digital radio standard, or 8BSB or DVB. These are all high crest factor signals. And you really can't track them very well with, you know, a thermocouple's got too much latency, and the diode doesn't have the dynamic range. So if you're using a diode style meter to measure, you know, to measure things like digital, you know, the digital FM system or even the AM system, that's really not the appropriate way to do it anymore. So,
I was just pointing out that everything old is new again sometimes.
well, that's right. That's right. You know, when you think about it, the thermocouple principle is really no different than what we do in terms of, you know, the end result, because, you know, it's what are you doing? You're taking RF and you're heating up an element, and it's a pretty simple physical principle, and that's pretty much how it works. But we're doing it with active electronics, but the end result is the same. You do get an RMS RMS sum, and that's, by the way, how, you know, again, you know, I've seen this where you know, combined systems, you know, you go in there and you see a bird slug or a coaxial dynamic, and I don't mean to pick on bird or coaxial, not really, I mean, but that's the wrong way to measure that stuff. You can't measure multi-carrier with a diode. The old way to do it was with a crystal detector, but you know, we can do that very easily. Multi-carrier is not a problem for us at all. Do it all the time.
The LMR world, I've noticed that one of the interesting things is an active digital signal like that. It's going to vary a little bit. It's not going to be constant.
Correct. All righty. So, anybody else have any potty to throw at me?
Go ahead, Keith.
Oh no, I just want to say, enjoyed it. You know, it's a terrific show, guys. And thanks, Bob, and thanks, Barry. It was informative. Bob
Yep.
can take us to school.
Well, we
Want you to know
appreciate.
that Keith and Jeff Schick work with us actually, and they do all of our social media stuff. So if you've seen us pop up on social media all of a sudden, you can blame this guy right here.
Oh no, just good to learn here.
Well,
Thank you, gentlemen. Appreciate everybody's time today.
thanks. We'll see you again soon.
Thanks, Bob. Thanks, Barry.